Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic. In this video, I'm going to talk to you about conventions that we adopt in writing our proofs. The proofs I've given you so far have been written out extremely explicitly. So every single step, the writing down of propositional tautologies, the applications of modus ponens, the uses of uniform substitution have all been done explicitly. We do this in part to show that what we are doing are actually proofs, but also because when you're first learning how to do proofs in a modal axiomatic system, you need to know exactly what the steps are before you can start skipping steps. So it's really good in the beginning when you're first practicing to work through all of your examples in excruciating detail. However, once you reach a point where you start to get a sense of how these proofs work, how they work, what's going on, and things like that, it can actually make it harder to understand the structure of the proof by being forced to do all of the steps explicitly. So I'm going to give you a bunch of conventions that I will be using in my proofs going forward, and these are also conventions that are kind of generally accepted in the logical community. The first is that once we've proven something, it's proven. We never have to prove it again. So if we want to say, call the two theorems that we've proven so far, K1 and K2, then at any point in the future, I can just write one of those theorems down, annotate it, K2, and I don't have to prove it again. Now, the use of the name K1, K2 is not uniform across all kind of approaches to modal logic, because it's kind of happenstance that these are the ones that I picked to prove first. However, in any given context, once you've proven something in that context and you've given it a label, feel free to refer to it again. The second is that writing down a propositional tautology and then doing uniform substitution on it to get a substitution instance seems a bit redundant. What we will do is we will allow ourselves to simply write down the substitution instance. The annotation for this will then be propositional logic, PL, plus uniform substitution and an articulation of the substitution instance. The reason why this is unproblematic to do is because given this information, you can reconstruct, you can kind of like de-substitute and figure out what the original tautology was, double check that it really is a tautology if you feel that you need to, and things like that. Similarly, we will often have we'll do this with the axiom K. So instead of writing K down and then writing down a substitution instance, we can just write down something that is K plus uniform substitution. Another thing that we will do is we will start suppressing applications of modus ponens. Modus ponens always happens through substitution instances of propositional formulas because we have some sort of implication, substitute into it, so we've got modal bits because we're doing modal logic, and then we have the antecedent, which also has modal bits in it probably, and then we can detach the consequent from that. However, if we already have the antecedent and we know that that antecedent is the antecedent of a substitution instance of a conditional that has a particular consequent, instead of writing down that entire conditional and then writing down the consequence and saying modus ponens, we will just write down the consequent, generally annotated with propositional logic with reference to the line that we got it from. So in particular, we might want to have something like, let me bring up my board and then I can show you exactly what I mean. Now, suppose that we have, I don't mean that, we don't have scope lines in propositional or in modal logic. Suppose that I'm able to prove phi implies psi, and I've also proved that gamma implies psi. Now, it is a propositional tautology that if P implies Q, then if R implies Q, then either P or R implies Q. So propositional tautology. So there, we're just assuming that we've already proven lines 1 and 2. Then we have this propositional tautology that says if you've got two different conditionals which each go to the same consequent, then if you take the disjunction of the antecedents, that also leads to that consequent. And then, a substitution instance of this would get us that phi implies psi. If that's true, then if gamma implies psi, then phi or gamma implies psi. So this is uniform substitution, line 3, with phi for P, psi for Q, and gamma for R. Now, our first convention would be that we don't even write down this line, and then instead of citing line 3, we just cite propositional logic. Then we've got two implications of modus ponens that can happen. So the first one, we take line 1 because it's the antecedent here. So now we know, okay, then if gamma implies psi, then phi or sorry, that one needs to be gamma. Phi or gamma implies psi, modus ponens, lines 2 and 4. And then another, sorry, not 2, that's number 1. Another instance of modus ponens, this time involving line 2, which gets us phi or gamma implies psi. So modus ponens 2 and 5. And then here's kind of our conclusion formula. This next, so the second convention that I articulated would allow us to also omit this step and omit this step and simply say that this line, line 6, follows from propositional logic, lines 1 and 2. So we are suppressing the propositional tautology that's going on. Essentially, what our proof conventions allow us to do is focus on the modal reasoning, not on the propositional reasoning. So we're going to take it as kind of for granted that you are completely conversant in your tautologies and you can recognize that 6 follows from 1 and 2 via a substitution instance of crossed out line 3. There will be other conventions that we will use as we go along the way. These are the two most important ones. The kind of combining of substitution instances and the statements of tautologies or the K axiom, and suppression of explicit propositional reasoning. The next way that we can introduce conventions into our proofs, which make them shorter, easier to read, easier to kind of see what the important structure is by the introduction of new rules. Now, just as in propositional logic, we had the basic rules, and then we had the derived rules and the rules of replacement. These allowed us to essentially take shortcuts in our proof. We're going to have the same thing here. Derived rules just allow us to cut steps out of our proof. So in the next video, I will give you some of those, and together we will kind of simultaneously build up a practice of proof conventions, extra rules and things that allow us to take shortcuts, and more theorems along the way. So I will prove theorems showing how we adapt and adopt these conventions. Until then, take care. See you soon. Cheers.